All right, so we are, um, hold on a second. Continuing on with our notes here in section 3.4a, we really want to understand how to analyze the graph of a polynomial, and so we need to understand some key features. Something called a relative maximum is the greatest value of points in a region, greatest value of the points in a region of the graph. Now, specifically, we've got to emphasize, folks, this is a y value we're talking about. So just because a coordinate has an x value does not mean that you don't need to understand relative mins and maxes are actual y values. Okay? Now, when they say in a region, do you want to know what the mathematical term is? They actually call it a neighborhood. Now, I know you're like, well, what? If you were to zoom in on this little point right here, okay, and you were just to focus on that attention, is there a high value inside that little region? And the answer is yes. So we call that a relative maximum value. Okay, so the y value there is called the relative max. Okay, now this graph also has what's called a relative min, which is a low value, a smallest value, but it's only in a small section of the graph. The reason I say that is because there's other terms like absolute max and absolute min. And this graph, according to this graph doesn't have either an absolute max or an absolute min because they keep going higher and higher and higher and lower and lower and lower. But absolute max, the greatest y value of the entire graph, does not exist if the end behavior is up, either end behavior. And then absolute min does not exist if the end behavior has a down in it. Either side has a down in it. So up takes care of all the absolute maxes, and down takes care of all the absolute mins. But you can still have relatives. So when you look at this picture, we have a relative max and we have an absolute max. Now, to be quite honest, absolute maxes are also relative maxes. Okay? So absolute maxes are also relative maxes. But a relative max, um, something that's classified as a relative max, will always be an absolute max. And then this particular graph has no absolute minimum because it just keeps going down, 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 down. And it doesn't have to be one side only. It could be both sides, but if it's got one side that's going down, then there is no absolute minimum. And there is one relative minimum in the middle. You can see that one. So I'm going to abbreviate this and call it a relative max, I should say. Let's back that up. Relative max, relative min. Here, we'll just use R. No absolutes. Absolute max, relative max, relative min, no absolute min. absolute min. No absolute max. No relatives. Now, the absolute min does qualify as a relative, but I think we'll try to stay away from that and, confuse people. Okay, the domain. Remember that negative infinity is on the left, positive infinity is on the right. If we were to smash this entire graph, all the points onto the x-axis, how much of the x-axis would be covered by something? I hope you would say a lot of it would be. In fact, I hope you would say all of it would be. So negative infinity to infinity. I think you're going to get the feel for it all the time. Polynomial functions, the domain is always the same. It's the range that can be different. But if you started pushing all these points up against the y-axis forever and ever and ever, it would cover the entire y-axis. So it's also got negative infinity to infinity. Now, the zeros of the function, it looks like we've got negative 5, negative 2, and positive 3. The y-intercept is at negative 15. Relative max, 7.41. Relative min, negative 18. When we get to pre-calc, we're going to say things like 7.41 at x equals negative 3.67 or something like that. And this one will say negative 18 at y equals 1. Or no, x equals 1. What am I saying? Absolute max? None. Or we could say not applicable, something like that. Any of those choices would work, but you could literally just say none if that would be what you would want to say. Now, what about intervals of increasing and decreasing? Well, this section right here looks like it's going up because remember, you have to go from left to right. So that's from negative infinity all the way to negative 3.6, repeating. Notice that I did not use the y value. These are x's only. And then from negative 3.6 all the way to positive 1. It's going down. Negative 3.6 repeating to positive 1. It's going down. But then after that, at 1, it starts to go back up and it keeps going and going and going. Once again, I never mentioned y values, only x's. Domain and range. Domain should always be easy. Range has a little bit of a trick to it here. The lowest value, that should be a bracket. the lowest value here is a negative 4.86828. And it goes up, up, up from there to infinity. Zeros of the function. Well, it looks like we hit the x-axis at -2 and at 0 and at +1. Y-intercept is 0. Did they ask for the y-intercept on the last one? Yeah, they did. Okay. So relative max looks like 6.24 at x equals -0.84. And the relative min, 0 at x equals -2. Or the -4.86828. Or we can abbreviate that. We don't need to have all that. We could say -87 at x equals 0.59. So two different relative mids, to be honest. Now, one of those relative mins is an absolute min. So maybe we should just put it down here. And then come back here and not include it with the relatives, just in case people, I mean, it's true, but it confuses kids, I know. Absolute max, none. Intervals of increase, so starting from left to right, so from -infinity to -2, it's decreasing. So -infinity to -2. But from -2 to 0.84, -0.84, decreasing. From -0.84 to 0.539, going down. Oops, -0.84 to 0.59. And from 0.59. To infinity, we got everything going up, 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 up. I had to stand up. That last example, I was getting too sleepy. So sorry for yawning so much or being tired or slow. State the intervals where the graph is positive or negative. Now, positive and negative, okay? This section of the graph is positive and this section of the graph is positive. So that's -infinity to -6. So it's based on the zeros, right? So we know that then we got -6 and we've got 0 and we've got 5. So all of these intervals are going to be based on those numbers. So positive, we got -infinity to -6. Then from -6 to 0, it's below the x-axis. Then back up here from 0 to 5. And then from 5 to infinity, we're back down on this section of the graph, the negative section. So a couple sections above the x-axis, a couple sections below, but it's all separated based on that. Now, notice that increasing, decreasing, talked about this earlier, increasing, decreasing, these are all about x values of mins and maxes. But not these intervals of positive and negative. That's all about the zeros. Don't get them confused. And don't use y values on the increasing, decreasing either. Kids use y values all the time. Finding relative max and mins using Desmos. Okay, so you've been given an equation, so I'm going to switch over and split my screen here in a second. All right, so I typed it in, but I don't have the greatest of pictures. If you put two fingers on an axis and change it to light blue, you can shrink or stretch just that one axis only. And then maybe if you want to stretch it out the other way to get a better looking picture, you can. But here's the picture of what we have. And it would be really nice if we knew zeros, if that's what they asked me for. And they do. They asked me for -5 and 0 and 1. And then they asked me for relative maxes. Oh, okay. All right. So we got 24.19 at x equals -3.19. And relative mins, well, there's got to be one in here somewhere. I'm going to try to, there we go. -1.38 at x equals 0.52. So, sorry, that 24 looks a little ugly. Eesh. All right, let's try it on the next one. Got to get my new graph drawn. Now, if you ever want to go back to the original default window, you want to click on this little house. It's the home button. You click on that, it goes back, and you can see the home button disappeared because I'm already on the home screen. Okay, so back in here and try this again. -x⁻³. And you can see the graph changes every time you add something new to it. -76x plus 96. So here's my weird looking graph. Maybe I stretch it out, shrink it down a little bit. Take a look at it. Need to find my zeros. 2, 6, and 8. Whoa. Relative max. Man. 5.04. Oh, no, 5.05. Can't round correctly. At x equals 7. It's going to be 7.1. And then -16.9 at x equals 3.57. That's how we use Desmos to do that. It does the heavy lifting, and we just have to look at it, click on the points, and those are nice when we can do those kind of things. But some of that you'll have to do on your own. Or you'll be given a picture on a test question, and you'll have to identify the things that you see in the picture. So that's enough for those notes.